as we talk about angle measure, we actually define angles with directions in terms of there's an initial side that opens to a terminal side. And that is where, so if we have any angle, right, typical angle, we have what's called at the initial side and the terminal side, and it opens from the initial to the terminal. Okay, and that's why when we talk about angles, whether they're in degrees or radians, is that sometimes they'll be positive and sometimes they'll be negative. Okay, so we define this as if it opens counterclockwise, it's positive, and if it opens clockwise, negative, right? That should be, we should be good with that, I hope, right? That's the first thing on your paper there. So in a coordinate plane, an angle can be formed by fixing one ray called the initial side and rotating the other ray called the terminal side about the vertex. Okay, because what we're going to do today is use this idea of angles and this opening idea. Well, we're going to talk about arc length and sector area today, and then moving forward, we're going to talk about linear speed and angular speed and make predictions on how far things travel in a circular path, using the same idea of this central angle opening. We also talk about standard position. We've talked about that a lot. Right? If it angles in standard position, we know that the initial side is on the positive x-axis. And then we know that the vertex is at the origin. Right, so we've done those a bunch, right? That's all that we did with our unit circles. We were good with next week with that. Now, the two ways that we're going to measure angles, right? We should know that. That would be radians and degrees. Most of what we do here for the next little bit, we're going to be really focused on radians. Okay? Probably most of what we do in this course is focused on radians. Unless you're actually measuring triangles, then you tend to use angle or degrees. But other than that, we use radians. So any equations, if we're solving equations, we use radians. When we're doing these angular speed and today's arc length and sector area, we're going to use all radians. The reason is, if you remember how we constructed a radian with an activity earlier, is where we did the strings around the unit circle, right? But if you think when you find a radian, it's the arc length divided by the radius, correct, of a circle, and we'll see more of that later. But both of those would have the same unit, so they would cancel out. So radian measure has no unit associated with it, is why we really like it. It's really going to be handy for us, and we'll see some instances of that here later today. So now we know that in a full one revolution or a full circle, there are 2 pi radians or 360 degrees in a circle. Should be nothing new. And then our conversion factor that we want to use is that pi radians is equal to 180 degrees. Now you will see formulas sometimes, but I would highly, highly recommend that whenever you're doing this, you just do dimensional analysis. Go back to freshman science class or hopefully some math course, or I'll show you how to do it, but just using the dimensional analysis idea is much, much easier. You don't have to remember formulas. All you need to know is some equivalency. Right? You need to know that pi radians is the same as 180 degrees, and it'll always work for you. So the first thing we want to look at today is just how to convert. Just review how to convert from radian to degrees. And with that, we have 724 degrees. We want to convert this to radians. Now, also remember, whenever we're in radians, we love to have pi be there as the symbol pi. Right? If we can have it there, we want to keep it there as pi. When we're in degrees, we don't. So if it's in degrees, if you have pi there, you want to actually use your calculator to figure out what angle that would actually be. So to convert 724 degrees, We know degrees need to go away, so we're going to say 180 degrees on bottom. We're going to say pi on top, or you could say pi radians. Again, radians is a dimensionless unit. It's just a label to tell you it's not in degrees. So pretty much if you see a pi, well, anytime you see a pi, you should assume it's going to be in radians. And if you put a degree, you have to have a degree symbol. Okay, so to do this one, we're just going to multiply 724 times pi. The degrees cancel out. This is a case, you could reduce that by hand if you wanted to, but most likely you're going to use a calculator. So make sure you can do that and get the correct answer. So I'm going to do 724 divided by 180. And the best way to do that on your calculator, now don't type pi, because if you type pi in your calculator, it's going to actually put the decimal equivalent. So 724 divided by 180. And then on the TI, you're going to hit the math button. And then if you hit 1, it'll just convert it into a fraction for you. It just reduces it automatically. So math 1 is the quickest way to do it. And then you have to hit enter. So it gives you 181 over 45. So this is 181 pi over 45 would be our conversion there. We good with that? So again, just that's how you can always reduce take a decimal and turn it into a fraction using your calculator. Is that math 1? Now if you put an irrational number, like say you get the decimal for the square root of 2 and you try to do it, it won't do it because it's irrational. But if it is a rational number, it will convert it that way. So the next one we have is negative 17 pi over 3. We want to convert that. Right? It's got a pi in it. There's no degree, so we know it's in radian. Right? So for this one, we want the pi to go away. If it's in radians, we need to multiply it by degrees over radians. So we're going to multiply it by 180 degrees over pi. And the pi's will cancel. And then we just have to multiply. So 17 times 180 divided by 3. So this gives us negative 1,020 degrees. Everybody, just make sure you're able to get the same values. Now if you're doing it by hand, probably I'd say do 180 divided by 3 first to get 60. And then 60 times 17. Make it a little bit quicker to work that by hand. Now the last one we have here is 5 radians. Okay, now read this as it's written. This is just the number 5. There's no pi here, correct? It's not 5 pi. It's real common for people to kind of add something that's not there. It's just 5 radians. So we know it takes, what, about 6.28 radians to go around the unit circle. Right? So we were expecting something less than 360, but we still use dimensional analysis. Here is a time where you probably want to write radian. If you got pi in it, you're probably fine leaving it off. If you just see a 5 as an angle, technically it's going to be a radian because there's not a degree listed. But just for clarity, if it's just a number, you probably want to say radian. Just to be like, hey, no, I didn't forget to write degree. I really meant 5 radians. That's why in your calculator, when you're using sine, cosine, or tangent, it's so important to be in the right mode, because if you're in the wrong mode and you type in 5 and you mean degrees, it thinks you mean radians. It's a completely different angle. Not even the same ballpark. So we're going to take 180 degrees over pi radians. So the radians cancel. Now we don't want pi to be in our answer, so we're going to do 5 times 180 divided by pi. And that's going to give us approximately 286.5 degrees. Now that's rounded. I'd say round to 1 decimal place for angles is usually good. Think about a protractor when you're graphing stuff. It's hard enough to get the right angle, like the right whole number, let alone a decimal place. So I think 1 decimal place is sufficient. If it says, write a 2, go to 2, I would think that would be All right, we good to go there with that? Should be review there. Okay, the next thing we want to look at is a coterminal angle, what coterminal means. And we've talked a lot about these. And it's angles whose measures, I'm not sure. What's it say on your paper there? Does it have a thing? Coterminal angles, yeah. Well, that's not really a good, I don't know what that is all about. I might scratch that out. I would just say probably a better definition is coterminal is what we're going to talk about. Coterminal angles. These would be two angles in standard position. Right, so again, we talked about standard position, vertex on the x-axis, right? Or vertex at the origin, initial site on the x-axis. Two angles in standard position have the same initial and terminal sides. That would be a good definition. So they're basically a even number, there are some number of revolutions different, correct? Like a 180 and a 540, or a 0 degree and a 360 degree. Mathematically, coterminal angles differ by a multiple of 360 degrees or 2 pi radians. Okay, so that should hopefully make sense there, right? We talked a lot about coterminal when we did trig ratio, sine, cosine, tangent. You could subtract 2 pi, you could add 2 pi to get it wherever you needed it. But just be aware, it is 2 pi. So, and when you say multiples, it's whole number multiples. So they could differ by 2 pi, or 4 pi, or 6 pi, or 8 pi, right? But not 3. 3's wrong, because it's not a multiple of 2 pi. Okay, so the easiest way to find these generally is just add 360 or subtract 360. If it's in degree measure, or add 2 pi or subtract 2 pi. You could do it like that. As they get really big, sometimes there might be some other tricks we might want to look at to make it a little bit more simple to calculate. So let's see here. We have a couple examples here on your paper. I'll maybe do a couple for you. I think it should kind of make sense here. Actually, why don't you go ahead and take a few minutes and try these, and we'll come back and look at those at the bottom. Okay, so for each of these different angles here, we want to give one negative and one positive coterminal angle. So now, how many coterminal angles are there for each angle? It's an infinite, right? And then you could just keep adding 360 and just go forever. It'd be a big list. So what was someone give me what was a positive coterminal angle with 140? 40 with this? No. What's a positive coterminal angle? What would you add to this? You'd add 360, and you'd get 500. Yeah, 500. Right? And then how would you find a negative coterminal angle? You subtract 360, right? You subtract 360, and you get negative 220. Now, those are not the only two correct answers, but those are the easiest two correct answers, right? They're the closest to it. Again, you just took here, 140 plus 360 gets you 500. 140 minus 360 gives you negative 220. Here we have 0 radians. Well, 0 radians. We're in radians, so you add 2 pi, correct? So we get 2 pi. You could do negative 2 pi. You could do any even multiple of pi would be correct, but these would be good ones. Okay, 30, 390. I heard that. What's the negative one? Is everybody getting this? Okay, so negative 330. Good. And then pi over 6, we're going to add 2 pi. So let's see, pi over 6 plus 2 pi is pi over 6 plus 12 pi over 6 is 13 pi over 6. So that'd be the positive one, correct? Or you could have pi over 6 minus 12 pi over 6 and get you a negative 11 pi over 6. Okay. Now, what's important to realize is these are all different angles. They're all not the same angle. Because of the way we did trig ratios with the unit circle, if you do kind of get that confused sometimes, it's an honest mistake, right? It's an honest mistake. But what that means is if we look, say, at these three here, if we're going to sketch pi over 6, we know that's in the first quadrant. It would look something like that, right? We have the arc here that goes from the initial side to the terminal side, indicating the direction. So we can tell it's positive, etc. Now for the next one here, 13 pi over 6, it's coterminal, meaning we know where the terminal side is at, but its path, we would indicate that like this. Right? It does a full rotation or revolution, and then it continues on a little bit. And then negative 11 pi over 6, again, it's coterminal, same location, but it's negative, meaning it's going to go clockwise, and it's going to look like that. Okay, so 3 different angles that are all coterminal. So, you know, I know that they would all have the same trig ratios, but that doesn't mean they're the same angles. Right? It doesn't mean that if we're doing angular speed or the distance traveled around, it's going to be much different depending upon the path. Right? That's why, yeah, okay. And then the next thing, any questions with that? Everybody good? Okay. All right, next up, find the coterminal angles in the given intervals. So very similar, right? But here we're kind of directed as where to go. A lot of times with these, people just tend to add 360 or add 2 pi until they get to the right spot, which is fine. Sometimes you can take some shortcuts, and we'll look at how those might work on some later things. But with this one, here we have an angle of 50 degrees. We want to find a coterminal angle between 360 and 720. So this one, you're going to take 50 plus 360, and that's going to give us 410. Now this is very similar to when we start solving trig equations. You're going to, because like when you're solving a equation with a sign in it, because sign repeats, you're usually going to get an infinite number of solutions for kind of this, a lot of them. So usually you're going to be given a little range, like find the answer between 0 and 2 pi, or between negative 2 pi and 2 pi. So it's kind of a good practice of thinking of that. Here we have 11 pi over 6. What's coterminal between negative 2 pi and 0? Well, it's negative, so let's subtract 2 pi. So here we get 11 pi over 6 minus 2 pi minus 12 pi over 6, right? Common denominator. So you get negative pi over 6. And then this one here, it's negative pi over 4 is our angle. And we want to find a coterminal angle between 4 pi and 6 pi. Now, I'm not sure how you did. A lot of people probably added 2 pi. Then you add 2 pi again. Then you add 2 pi again. And that, you have to add 6 pi is what we end up adding. But sometimes it's nice to sort of reason our way through that. We realize this is a negative, but it's just to the left of 0, correct? Right, so if you add, 2 pi to it, you're obviously not going to get there. If you add 4 pi to it, you're still going to be a little bit less than 4 pi. Right? Now we have to add an even number of pi's. So it ends up you're going to want to add 6 pi, and that'll push it back in there. So we get into the desired domain. So we get negative pi over 4 plus 24 pi over 4. That gives us 23 pi over 4. If you wanted to just check that with your calculator to make sure you're in the right, I would just do 23 divided by 4 just check that decimal value is 5.75 pi, which is between 4 pi and 6 pi. So it's kind of a decent way to check that. All right, any questions with those? Okay, good. So now let's go ahead and take a look at the back there and just take about 10 minutes and work through that with your